Thanks again for the kind introduction. I will start with giving a general idea or overview about the kind of services, repositories we are talking about today. And then I will switch focus to those repositories in the context and of HeFDI. And afterwards, Lydia will pick Data UMR as one of those repositories to give you some more details on such a service. What kind of service are we talking about here? Imagine yourself as a researcher that produces a lot of research data. You might want to store this research data together with your metadata in some form of central database. This is basically a research data repository where you can upload your data, put in additional metadata using forms, and then the data will be archived in that central place for at least some minimum of period of time. You can share the data with selected other individuals, or you can even make it available using the service to anybody who is interested in it, meaning you can publish your data using data repositories. I mean, why would you want to do that? One thing is obviously information and knowledge transfer. If you store the data in a central place, people will find it again. Think maybe about a future you who might want to access the same data again in a few years. Think about different researchers in the future of your own research group, but also think about collaborators, peer reviewers who might want to look at the data, the whole scientific world, and even beyond. The other thing is to confirm with rules and regulations. For example, the Deutsche Forschungsgemeinschaft guidelines on good scientific practice. There are several guidelines that specifically mention research data management. I will specifically point to Guideline 13 and Guideline 17 today. Guideline 13 is about publishing research results, and it says that when you publish results, you should also make your research data and all materials information and on which your results are based publicly available. This also includes software and source codes, which is also, research data. Guideline 17 speaks about archiving research data, and it even specifically mentions repositories. It says that you should archive your research data in an accessible and identifiable manner for a period of at least 10 years at the institution where the data were produced, or in cross-location repositories. So what do repositories do so that they are good at a good place for data archiving? Well, let's have first a look at the life cycle where the research data, where the repositories are located in the life cycle. Most of you who have ever attended a research data management talk before have probably seen some version or other of this slide. It's a model about the different stages research data goes through when during a typical research project. It starts with planning, collecting, processing, and analyzing. And as you have guessed from the earlier slides, repositories come mainly into play in the later stages of the research data life cycles, mainly when it comes to preservation of the research data and also when it comes to provision of access to other people. To allow these features of repositories, you can do specific things with those. You can obviously upload data and input metadata, usually using forms that have been tailored to the metadata model of the respective repositories. You can assign persistent identifier to the data, for example, a digital object identifier, but you can also often link persistent identifiers to the authors of the data, such as the open research and contributor identification. These repositories allow data sharing with specific individuals, such as in your team or with outside individuals upon request. They allow you to assign licenses, though that everyone who downloads the data knows exactly what he or she is allowed to do with them. They allow for download of public data sets and often also to create new versions of existing data sets. On the other side, they have functions to search for data within the repository, and often they are also indexed in outside data discovery systems so that you have central search entry point. Research data repositories are usually subdivided into classing using or by their target audience by asking questions like who can submit data sets to the repositories, or also researchers of which fields might be interested in the contents. Like that, you can distinguish, for example, between discipline or subject-specific repositories, generic repositories, and institutional repositories. Subject-specific repositories are often the first choice of repositories if you want to store and publish your data, as they are available for anyone in the field without the regard of data origin, and as they are such a central resource in the respective field, they also give a high visibility to the uploaded data sets. They typically have fitting domain-specific metadata schemas. They are run by discipline expert, but they might be limited in some regards with their service. For example, they might only allow publishing of data set and not archiving your data without having to publish it. If you go to a discipline-specific repository, you should make sure that it's located at an institution that can make sure that it's run permanently, and still such a repository might not be available in your field yet. To check for that, the database registry of research data repositories is a very good entry point. HeFDI-Data.org lists more than 3,000 repositories, and using search filters and search functions, you can, for example, identify discipline-specific repositories, but you can also filter for other things like data types, metadata standards, the licenses you can assign if there are access restrictions, and so on. On the other end of the spectrum, there are generic repositories, which you could also call catch-all repositories. They are not tailored to any specific discipline, nor are they restricted to a specific data origin. They typically have generic metadata schemas. Some of them are hosted by large public institutions, with most famous probably being Zenodo, which is hosted at CERN and is a not-for-profit repository. And finally, we come to the institutional repositories. They are kind of a subset of the subject-agnostic repositories, as they are run by research institutions with a limited scope of archiving and publishing data from that institution. So they are a subject focus is depending on the institution that runs the repository. There are several institutional repositories exist and come from the HeFDI context, and I will introduce those in a moment. But first, have a look while you might want to go to institutional repositories with your data. Those are suitable for data for which no discipline-specific repository exists yet. More and more discipline-specific repositories are being set up, but they are not there for all disciplines as of now. Scientists might want to prefer that to store their data at home at an institution, or they want their institution to be under control of the data they upload. They often allow a very differentiated assignment of rights, also in working together with the identity management of the respective institution. And also they allow long-term storage of the data for the archiving purposes without having to publish it if some legal or practical reason oppose publication. As I said, there are several institutional repositories in the HeFDI context. For Marburg University of Kassel researchers, there is DAX. For data UMR, for Marburg, there's data UMR, which Lydia will talk about in a moment. For Gießen, there is JLU data. Since a few days, we have a new addition to the family, which is Gude, which is from the University of Frankfurt. It basically has started its public test phase just a few days ago. But researchers from the universities are already very welcome to upload data there that will also be kept long-term. And finally, we have the repository from my own institution, ToDataLib from the Technical University of Darmstadt. One specialty from the HeFDI context about ToDataLib is that its service has been expanded to different universities of applied sciences in Hesse, so that those researchers can also upload and archive data there without the institutions having to set up their own institutional repositories. Researchers from the Universities of Applied Science in Darmstadt, Frankfurt, Fulda, Geisenheim, and also of the UAS Rhein-Main are very welcomed and encouraged to use ToDataLib as well. And with that, I will hand over to Lydia, who will introduce data UMR as one example of those repositories that all have a very similar technical background and are therefore very similar.
Great. Thanks a lot for this great introduction and overview. I will refer back to the good scientific practice that Andreas introduced, and I will go along some essential aspects to introduce data UMR. So let's switch to this picture. Like, this is the starting page of data UMR. And this is currently running with DSpace 6. This is a software for repositories, and it is hosted by the University of Marburg. We are going to migrate the repository in some month, so it will change a little bit, but the features will stay and will be expanded. So okay. One special service of data UMR is that this repository is curated, which means that you, as a researcher of University of Marburg, have the opportunity to upload your data, but it's not publicated immediately, but before publication, we will go through it like in a mini review process, so to speak, to check whether your data is fair and give some hints to how to make your data fair. And this is this FAIR principle I talked about. Like fair data, I guess most of you already heard about fair data. Fair means that data should be findable, accessible, interpretable, and reusable. And this is in the end what Andreas already talked about. It's good scientific practice to make your data fair. And I will try to introduce the features of data OMR using this FAIR principle. And we once created a comic. I'm sorry, it's in German, but it's like the Marburg data management comic, so I used it here. Yeah. Like data UMR supports you to make your data fair, as I said, and the first aspect of fair data is findability. So how does data UMR supports findability? Well, first, our repository is supporting PIDs, like persistent identifiers. So you can register a DOI for your data and make it persistently findable through that. We do have rich metadata options to support you describing your data in a very detailed way. And we use a metadata scheme that is human readable and also machine readable. So you as a human can go through the data sets that we store and understand what is there and what's the context of the data, but also you could search them using programs, for examples. So this is an example of a data set, and you can see we have like a part of the metadata here and also the DOI of this data set. So this is how a usual data set looks like. So the next aspect of fair data is the accessibility. How does data UMR supports accessibility? Well, data should be made as much available as possible. This is one aspect, and they should be preserved. And data UMR supports you doing that because it's an open repository, so you have the option to publish your data openly. But you don't have to publish all all bit streams of your data set because sometimes it's difficult to publish all because of some rights you might not have on your data. So we support differentiated rights assignments. We support an embargo, so you could also decide to not publish your data immediately, but after some time for some reasons. And we support you through consulting and support. As I said, the repository is curated, and so you'll have some support from people who are working with data. Yeah, and data UMR guarantees preservation of your data for a minimum 10 years. And we also support you in our consultation with the file types that are suitable for archiving. So we support you with preparing your data set to make it long-term available. So, and here is a screenshot of a data set where I wanted to show you that we have this differentiated rights assignments. So you have here a README file, for example, that's freely available, and another file that's not available for free. So yeah. And this is just a form for assigning the embargo that I talked about. The third aspect of fair data is interoperability. Interoperable data means that your data should be available in such a way that it could be exchanged, interpreted, or compared with other data. And we support you doing this through the possibility of referencing data records, for example, with relation types. Here, you see that we have a relation is supplement 2. So this data set has a related publication in form of an article, and it is supplemented by a GitHub code. So this data set could be used, yeah, you could read about the context and you can use the code to work with the data. And the last aspect of fair data is the reusability. And reusable data are well documented. It is transparent how the data is, how they were collected or generated, what variable names are, for example, if the data is raw or processed, like all the information about your data that people could find helpful is part of a good documentation. If something changes in your data set, also a versioning could be helpful. So the versioning means that it is transparent how your data set changed and why, and which parts of the data set changed. And reusability also means that you give rights to the people to use your data, but you have the opportunity to choose what the people are allowed to do with your data. And this is possible through licensing. Versioning is possible in data UMR, and a rich documentation is possible. So as you can see here, a lot of context is given, and during the curation process, we support you with the documentation because mostly we are not from your subject, from a specific field. And if we understand the context of your data, it's really, really well described. So it's also possible to give different licenses to choose what people can do or are allowed to do with your data. And that's mainly it.
Thank you very much.